Okay, so we're on to the second of our kind of lightning-ish talks. David Kerr works for the ONS, Senior Geospatial Analyst at Office for National Statistics, background in GIS application development and population modeling. So over to you, Alex.
Thanks very much. Okay, thanks very much for sticking around for what I hope will be a fascinating introduction to hierarchical grids. Sorry, can you hear me okay? Okay, fine. So yeah, I'm David Kerr. I'm a geospatial analyst with the ONS. I work in the geospatial team in the Data Growth and Operations Directorate for the ONS, where we're trying to help other ONS teams and civil service teams make use of geospatial methods and data in their analysis. So I'm going to talk about some work we've been involved in producing these hierarchical grids as an alternative but not a replacement for small area statistics in the UK. It's important to say it's not a replacement, it's just a different way of doing things. So I will talk about the current implementation of small area statistics in the UK, introduce these new hierarchical grids I've been working on, how they're made, the Python package that we've developed to make them, and finish off with some examples and use cases for the outputs. So currently in the UK, individual data such as census demographic data are aggregated up to output areas to mask any, to disclose finding out anything about individuals or groups within the data. So these areas are predefined before the census data is collected, and these points are aggregated up to these areas. Sorry, it's a bit slow. Okay, so these current geographies with these irregular geometries are not ideal for integrating with other data sets. For example, environmental data. So what has been developed is these 1 kilometer grids with the census data has been disseminated in them, but they are a bit limited in the number of demographic variables in the data set. And also there's also a requirement for finer granularity in these 1 kilometer grids. So with these hierarchical nested grids that we've been working on, we are developing these areas based around the data itself rather than predefining the geometries before inputting the data. So we join the individual data to these 1 kilometer grid cells and then aggregate them up. And then from these aggregations, we're trying to split these grid cells into smaller, increasingly or decreasingly smaller grid cells so that we can get as much variation over the data set, but still keep the disclosure limits rules kept. So this is the kind of output that we're looking for with densely populated areas in the small grids and smaller sparse populations in the larger grid cells. So at the moment we are working in a range from 1 kilometer down to 125 meter grid cells, and in each level these disclosure rules are kept. So we've developed this Python package using open source libraries. It's just pretty much GeoPandas, Shapely, Fiona, and the usual suspects. As well as the input demographic point data, you need, at the coarsest level, you need these 1 kilometer grids snapped to the British national grid. And then at the finest level, you need these 125 meter grids that nest perfectly within the 1 kilometer grids. the user running the tool then defines thresholds that they would like this data to meet within these cells. And then also some rules that are used to classify the cells to determine whether they can be split down further. So the classification rules are, on the left is an example of how these classifications are defined. So the box in the right shows the different classes that determine whether the grids can be split down further. So class 0 is unpopulated, so nothing gets done with this data, or nothing gets done with these cells if they're aggregated to this class. Class 1, they're below the threshold, and they're deemed to be small enough to be passed around to neighboring grid cells within the parent grid cells to bring them over the threshold. Class 2 cells are deemed to have failed the test, so they will be dissolved up to the parent level along with their neighboring grids in the parent. Class 3 cells can take cells from neighboring can take points from neighboring cells to bring them up above the threshold, and then class 4 cells are deemed to pass the threshold. So any points in excess in those cells are randomly shared to cells that need them. And this is all within the parent grid cell. So they can't go out of the parent, but they can be shared around within the parent. So you end up with everything in the parent being classified as class 4 or class 0, or it gets aggregated up to the parent level. So this is one example. So this is a 1 kilometer cell, and it's been split into 4 500-meter cells. They've been classified according to the population and number of households in the cells. So there's class 4 above the threshold, class 3, it can take points, class 1 can give points, but because there's a class 2 in this parent cell, everything fails and it goes up to the parent level. In another example, we've got 2 class 4 cells, so they can share excess points. We've got a class 3 that can take points and a class 1 that can give points. So in this scenario, we can bring the class 3 cell over the threshold. The class 1 becomes a class 0, so it's still okay. And these cells can try to be split further. They don't fail and have to be aggregated up. So the code works by iterating through every 1 kilometer grid cell in the data set and tries to split these cells into as fine a granularity as possible until everything has either been sorted out and split down as far as they can go, or aggregated to a non-disclosive level. So we have an example here of some outputs we've done. On the left is using, well, this is just the census output areas with the dummy census data aggregated up to the census output areas. And then this is the gridded method that we've developed on the right-hand side. So on the east side is the urban area of Southampton, and on the west is the New Forest. So most clearly, you can see the a bit more detail in the urban areas, and you can see more defined densities in the urban areas in the gridded version. And then you can see a bit more detail in the rural conurbations around the New Forest compared to the output areas. And then one of the main things about this gridded method is that non-populated grid cells are removed from the data set, so that you can kind of determine how populations are distributed more effectively than the other version. So this is it zoomed in, sort of closer into Southampton. You can see a bit more detail in the city. And this is the same sort of format, but North Somerset and Bristol in the east. Yeah, as I said before, you can see a bit more detail in the cities and the smaller rural areas, and then the non-populated areas removed from the grid data set. And that's it, just zoomed in again. And then finally, it's just a comparison between the two methods in Greater London. It's quite clear to see where the populations are dense in the center of the city, and then also you can see, for instance, in the Test Valley, sort of going up towards the north, you can see how there aren't any populations in there. So it's quite clear where there is a lack of population. So this table shows the number of geometries that were output using the output areas for this data, compared to the gridded method using a threshold of 50 people. It's worth mentioning that the census data has a threshold of around 100, so it is a bit more detailed in the first gridded column. The second gridded column, we use a threshold of 100, and they're kind of comparable in the urban areas. And then in the more rural areas, you can see there's considerably more detail in the gridded version of the output. So some things that we've discovered with this is the gridded data sets don't nest perfectly within traditional boundaries. So it's not obvious to see which well, this is a local authority. It's not obvious to show which local authority these sort of outer grid cells are belonging to. So one thing we're working on is assigning 1 kilometer grid cells to different geographies, so that you know which areas they represent. Another problem is with these 1 kilometer grid cells, if they are below the threshold, they can't go to a bigger area, because that's where they start. So what we've done is adjust the below threshold populations to the minimum threshold. So if you sum the whole population of the gridded data set, it will be more than what the original data is. So we need some way of adjusting that population so that the whole data set will sum to what the original raw data set is. For some use cases for the data, we think it would make a good validation tool for things that have been for models that have been developed, and then it can be used to mask disclosive data in other settings, such as epidemiology, or combining with other data sets, such as environmental data sets, to see how things are changing in the sort of net zero or climate change and things like that. So yeah, we have published this code, or we will publish this code in the next couple of weeks. So we are welcome to any feedback or suggestions to make changes to this code, or we're happy for anybody to make use of this code for your own use cases. So yeah, if this is the repository, if you're interested at all, then please get in touch. Thanks.
Thanks very much, David. We've got time for a question or two. It's the break next, so Alistair has a question to kick off. So if you can repeat the question.
Okay. Deterministic. Is the data deterministic? I have only developed this code for the data. I'm going to defer it to my manager up there. Chris, Are you? Yeah. Yeah. Are you able to get the details of that person and we can get in touch? Yeah. Okay. Does the redistribution of grids only happen within adjacent grid cells? Yeah. So you start with the 1 kilometer grid cells. I don't know if I can go back there quickly enough. You start with the 1 kilometer grid cells and you split them into 4. So the parent is the 1 kilometer grid cell. You can't move points out of that parent. Then when you split the 500 meter into 4 250 cells, you can't move out of that parent 500 meter cells. So they're only constrained by their parent. So it's only shared between those three grid cells. Sorry, 4 grid cells. Yeah. At the moment, it's are the ONS planning to publish this data using this method? Yeah, census data. At the moment, this is just a proof of concept. So we're still talking to other departments to find out what we can do and what thresholds would be best, the most optimal to keep the data disclosive. So at the moment, no, but we hope to develop something.
Great. Well, thank you very much, David, for that talk. And round of applause for David. And half an hour break now. So we'll restart at 3:30. There is tea and coffee and quite a lot of cake out there. So please go and help yourself.
Thank you.
Great, thanks.
Yes, yeah.